Okay, Pre-Calc 1-4A. How are we doing out there today? All right, let's get to it. Lots to cover again. 1-4A, this is increasing and decreasing behavior. So 1-4, we're going to split into two sections, 1-4A, 1-4B. 1-4A is a little longer, 1-4B is a little shorter. Okay, so let's get to it because there's a lot on this one. All right, our objective today, we're going to determine intervals on which functions are increasing, constant, or decreasing. So it seems pretty simple when we think of it that way, that what we're looking at is just certain intervals meaning a certain point or a certain section, I guess, of the graph in which we're going to look at just at that section. Is it increasing, decreasing, or constant? So you see the graph over here on the right that we can look at over here, and also over here, just kind of look at the words as we go through them. So consider that graph on the right, and if you go from left to right, f of x is the function, and it looks like from the interval of negative infinity to -5, it is increasing or rising. Okay, so down here would be where negative infinity is. From left to right going this way, it's increasing, so it's rising from there. From -5 to 0 is where it's constant. It's flat, straight across, nothing happening. And then from 0 all the way to positive infinity on x, it is decreasing or falling. Okay, so we can kind of look at those. We see the picture, we see the graph, we see the terms increasing, decreasing, constant, rising, falling, flat. Okay, we can also look at those in terms algebraically. So let's look at our table here. So just another way to describe it, because I know sometimes the pictures don't do it. Maybe you're a word person, so we kind of give you words, symbols, and pictures here. But we talk about definition-wise that a function is increasing on an interval if and only if 2 points have a positive change in x, or if a positive change in x results in a positive change in y, or a positive change in f of x. So if we have 2 points, say x1 and x2 here, and an interval, they're calling that interval L here, just these pieces here, okay? If f of x is less than x1, or sorry, f of x1 is less than f of x2, when the same is true for those x points, okay? So if the y values basically rise, basically when the x value rises, that's increasing. So from here, you can see if we go from x1 to x2 here, and we kind of went upwards, so we're rising. So sometimes when we use all these variables and x's and x2s, x1s, it gets a little confusing. But basically, we just think about what we did up here. If it's rising from left to right, it's increasing. If it's falling from left to right, it's decreasing. If it stays the same, it's constant. Okay? And our interval here was from the section, or basically from here to here, from negative infinity to positive infinity. All right, decreasing, kind of the same, so we'll let you kind of go through the table here and figure that out, but basically all it's saying is what we did above. All this action here, they're just using different points and stuff. It's just saying as we go from point 1 to point 2, we're kind of falling here. So that's a decreasing interval. And then constant interval, in this case, if your y values stay the same when x1 gets greater when it goes to x2. X1 is less than x2 technically. So all that's basically saying on these is left to right on your graph, left to right. So as your x values get greater, right, x2 being greater than x1, then what happens with your y values, okay? So again, we're just saying we're going left to right here. So what happens here, this part means it's increasing. This part here is telling you it's decreasing. And this part here is telling you it's constant. So those are all kind of what we dealt with up here. Just a different way of explaining it, okay? All right, so continuing on, you can pause, rewind, do what you need to do on those as we go into some practice here. So all we're going to do here is we're going to use the graph of each function to estimate the intervals to the nearest 0.5 units, okay? Now, a couple different ways we can do this. As you can see, it says, so the nearest 0.5 units on which the function is increasing, decreasing, or constant. So we're going to kind of look at it and give us one of those. And then that part's kind of easy, but the bummer part is this part here, support the answer numerically. We'll show you how to do that. Okay, that takes a little bit of time. with some tables. So first, let's take a look at our graph here. So we can kind of look and see that it's decreasing from here all the way down to this point here. It's kind of decreasing. So when we see that, we can say that F is decreasing on that interval, which is basically from negative infinity to the left all the way to this point here. Well, this point happens to be at 1, 2, right? 2. So at 2 is where it stops decreasing, and then it starts to rise up. Okay, so we say F is decreasing from negative infinity to 2, and and sign, not an infinity sign, and then it starts to increase, right? It starts to increase from here going up. So from 2 all the way to positive infinity, it's increasing. So we would write, and F is increasing on the interval 2 to positive infinity. Okay, so we kind of see that with the graph. That's pretty nice. Now, the bummer part of it is when we have to make this table now to kind of demonstrate it. So you have to make 2 tables based on your intervals here and here. So that's what we'll do down here. This is where we're doing the support the answer numerically. So we kind of show that ourselves. So our first interval we're going to do is negative infinity to 2. Okay, so we're just going to write those up there and say, and make our table. Okay, I'm going to make it large because our writing is not the greatest. I know that. So we have x here, and then we have f of x right here. We'll split those in half. Okay, and now we need a lot of values in here, so that they're giving us 6 values, just so we can say we know. I know when we graphed with linear equations, we only used a couple points, but here we're going to put 10 points on there. So we're coming from negative infinity. Then our graph, we don't have a whole lot, so a lot of space here. So we're just going to start with like negative 10 and negative 8 and negative 6, negative 4, negative 2, and 0, because it kind of goes that direction. And then we'll kind of have to plug in those to get our x values, or our f of x values. Again, we look at the function. The function is right here for us. So when we plug in these numbers, we're going to plug them in to these variables here. Okay, so I did a little bit of math for you here, and we end up getting some large numbers in here. So our first one, when you plug in a negative 10 into this function, you end up getting, I think it's 285. Negative 8 would give you 197. Negative 6 gives you 125. Negative 4 gives you 60. Say it's 65. Can't read my own writing, something like that. Just put a question mark there if you get something different. Negative 2 in there gets us 29, I think. And 0 gives us 5. Okay, now let's kind of take a look at that and see. Oh, and just double checked there. Yeah, so I was a little bit wrong on those. 69, 29, 569, 29, and then 5. Okay, so we can kind of take a look at our on our table here. That, yes, this definitely shows that we're decreasing. Look at our values here. They're going from 285 all the way down to 5, so we're definitely decreasing. So that's how we support it numerically, okay? But we also have to do one for this interval here of 2 to infinity. So we have to do that again. We'll make another table. Just try to pop that up here, okay? So we'll make another table. This one we will title 2, comma, infinity. And then we'll put the boxes here again. x, and then we got f of x. Okay, and then I got another 6 values, but this time we're going to choose values on the other side of 2, right? Because that's where we'll start. So I'm going to start low. I'm going to go 4. We'll go 6, 8, 10, 12, and 14. And that'll kind of give us a bunch of different values there. Now, when we show what we do and put in the function, again, you're just putting it into this function right up here. That's what we're looking at. Plug in these values and get your answer. So this is what takes a little bit of time with it. So when you plug in 4, you get 5. When you plug in 6, you get 29. Plug in 8, you get 69. Plug in 10, you get 125. Okay. Plug in 12, you get 197. And 14 gives you 285. Yeah, 285. Okay. So what you'll notice that those numbers are kind of the same as what you saw here, just in reverse order, because it's a special type of function that we know as a quadratic, as a parabola. It has symmetry, so we can see that those numbers are the same. But if we look at these numbers down here, they're definitely going up. They're definitely increasing. So supporting it numerically, so when we looked at the graph, we could estimate it right here with this part here, but then we have to support it numerically with the table down here, okay? So let's work again on 1b. It's a little bit different because of the constant, and then we'll kind of save time by letting you guys kind of work on the table, or maybe we'll do it in class together. But let's just look at this function together for right now. All right, so again, if we start on the interval negative infinity here and go all the way up to, say, about this point, it's about -3 on x right here, right? -1, 2, 3. Yep, so about there on x, and then this would be kind of negative infinity. And then over here, we're saying probably about -3 on x right there, okay? So that interval there of that piece, we're definitely on an upward trajectory, so we're increasing there. So we could say that that h, this is function h, that h is increasing and it's increasing on the interval negative infinity to -3, okay? And then what's happening on the other side? So then we could say h is, well, now it looks like it's flat. So that would be definitely a constant, right? So we could say that h is constant from -3 all the way over to where we're at infinity. So we would say, and constant on this interval of -3 to infinity, okay? So that we could do, that's the fun part, that's the easy part, just graphing it without the table, okay? So when we make our table to support it numerically, yep, that's the bummer part. It takes a little bit of time, but it's just punching in numbers. Remember, you're going to use this function here. Now be careful because this is a piecewise function, and it has a couple different things to it, okay? So when we do this, when we set this up, again, our first interval is going to be negative infinity to -3, okay? And when we plug in our values, again, x and then f of x here, okay? What values am I going to use for x? So again, I've got to start kind of before -3 because that's my endpoint there. So I'm going to go with -9, -8, -7, -6, -5, and -4, okay? So when you punch in those values, what you're going to see is that it is increasing. Okay, so it's increasing, and we'll show you by what you get. I'm kind of saving you the math on there, but all we're doing is plugging those numbers in here. Now, because it's less than -3, or less than -3.1, we're actually going to use this equation, 3x plus 11 there. And so we end up getting, what, -16, -13, -10. It's kind of a linear equation. They're all moving up constantly. And then -1. Now, what you notice with the other side of things is that when we do the other interval, which would be -3 to positive infinity, what you're going to see, again, as I make my table, you're going to see something a little different. So now, again, I got to use numbers that are above -3. And so, because that's my spot on the interval where I thought it changed, so to support it numerical. So I'm going to use -1, -2, 0, and then 1, 2, and 3. Okay? So when we do that, what you see is now we have to use this different part of the function because we're putting in numbers that are greater than 3.1. So now our answer, it says it's always 1.7. So when I do that, when I plug in the values here, it's a little bit easier because the function was a little bit easier for us because it says no matter what, these are always 1.7 because they are numbers that are greater than -3 in our piecewise function. And so that shows it supports it numerically. Okay? All right, moving on. Next page. All right, so a lot of definitions here. I'm going to let you guys kind of write them. I'll go over them, but then pause, rewind, do what you need to do to get these written down on your notes. So critical points. These are points that are tangent. They're drawn tangent to the curve, and it's horizontal or vertical. Okay, so right, the line drawn tangent. Remember, a tangent is going to touch the curve one time. Okay, one place. So that would be a tangent line. Extrema, those are critical points at which the function changes increasing or decreasing behavior. So it might change from increasing to decreasing. It might change from decreasing to increasing, things like that. We've talked about maximum and minimum before. Maximum is where the curve changes from increasing to decreasing. Minimum is where it changes from decreasing to increasing. So we've talked about those before as well. Okay. Point of inflection. So this is where your graph changes its shape, but it does not change how it increases or decreases. Instead, it might change the curve. Instead, the curve changes. Okay. Instead, the curve changes from being bent upward to downward or vice versa. Okay, so you can pause that, do whatever you need to get those definitions down, and then let's take a look at the graph at some of our stuff here. Okay, so you can see you have a maximum here at this point. You've got a minimum down here. We've talked about those before. We should know a little bit about those. Here's this point of inflection, right? It doesn't change. We don't change increasing to decreasing here, but the curve changed the direction. Okay, and then you have these lines here, which would be these tangent lines, and your critical points would be here and here when we draw the tangent line, and it only touches that curve at one point there. That would be the critical point. Okay, and your critical points are maximum, minimum, and we call those extremas. They're all part of that same idea. Okay, so here is some things, a table again to look at and just kind of go over a few things in here. When we look at this, just talking about relative and absolute extrema. Okay, so we talk about maximums. We have a relative maximum, and then there's absolute maximums, and then we do the same with minimums. But a relative maximum here is the greatest value that it can attain at some interval on the domain. So we can talk about this being a f of a. It says it right here. This part right here is a relative maximum of f, because in this total interval here, that is the maximum value. And then f of b up here would be the absolute maximum, the absolute maximum, okay? As we talk about absolute maximum being here, okay? So if we have a relative maximum that is the highest over the entire domain, so now we're talking about the entire graph, the entire function. If that's the highest point, if that relative minimum is the highest point, well, then that would be considered an absolute maximum. Okay, so relative maximum are just maximum that are there. They're not the largest point, but they are maximums before an increase or decrease change. And the same with absolute would be the greatest one, the highest one for a maximum, the lowest for a minimum. Okay? And the same thing can be said down here about minimums. You've got a relative minimum. Relative minimums are where it changes from decreasing to increasing, as right here. You can see it's coming decreasing, and then it's going to change to increasing. So this would be your relative minimum. But then, because that's just over this particular interval, this particular section of the graph. But if we took a look at the entire domain, the entire graph, well, this minimum down here would actually be a little bit lower. So of the entire graph, of the entire domain, we'd say it has the absolute minimum. Okay. So now let's continue on to the next page. If you need to look at that some more, read through it, go for it. It's always there for it on your own. And then this practice here, estimate, classify the extrema for the graph in this function. Okay. So this one, we can kind of look just at the graph and get some information from it. And then, of course, it says to support it numerically. What we can do here is we'll take a look. You'd have to kind of punch these numbers in and see where they fall. But we can kind of get, an idea of what they are and get an estimate. I'll kind of save some of that work for you. You just have to punch them into the actual function to get your answers. All right, so we can kind of see that there is a relative maximum here. Okay, so we would say that this is has a relative maximum. I was going to say relative, REL, and max right there. Okay, and that point was, if we just estimated, it looks like it's at like, say, on x, maybe negative 1.5. Okay, and then, and then our y value is slightly over 2. So if we're just to estimate it, like it says here, estimate, you kind of get that for us. Okay, and we also see that there is a relative minimum down here, right? There's a relative minimum right there. Okay. And the relative minimum, again, if we're just estimating it there, we would say, it's kind of at negative 0.5 for x, negative 0.5 for y. Okay. And then we also have one more up here, and that's actually going to be an absolute maximum because that's the highest on the entire domain. So we're going to call that an absolute max. And we can say that this looks like it's at about 1 on x and 1, 2, 3 on y. So if we were to guesstimate, that's what it would be. Okay, so then when it says to kind of support your numbers numerically, support the answers numerically, yeah, you would actually have to kind of plug some numbers into this function and see. And we see we're close, or you could graph it and trace it on your graphing calculator. We'll see we're close. The actual values numerically were actually negative 1.52 and 2.07. So we were really close. Over here, we were at negative 0.31 and negative 0.31. So we were really close there. And here we were actually 1.08 and 3.04. So that's kind of how close we were, but the actual numbers, we could support them by plugging certain numbers into these x's and finding it out, okay? Or, like I said, you could trace your graphic calculator and get those points a little bit better. All right, let's save 2B for you, just because I just don't want to go take too long, but I will tell you, you have a couple different points here to talk about. You're going to have a relative maximum here, and you're going to have a relative minimum here and here. Notice I didn't say that there was a absolute. No absolutes, min or max, and that's because this graph kind of goes on further in each direction, and it gets to higher and lower points. So there is no absolute max or min. We'll talk about that more. We'll have you guys kind of fill out those on your own if you want, so then we can take a look at it. And that'll save us some time here because I'm concerned about the time of the video already. So I don't want to take it too long. Now, this one also, if you graph your calculator, you can use a graphing calculator if you have one at home. If not, we'll do this one in class. But here's just some tips to kind of look at for this one. If you graph it, one thing you're going to find out when you graph this function here is you're probably going to have to adjust the window a little bit. Adjust your window. And then I would also use the zoom function and then the calc function. And then you can kind of find minimums and maximums that way. Okay. And I think just to tell you on your window, I think the best way to go is maybe go on your X, go -5, 5. For X, and then for Y, go -30 and 10 for your min and max on your windows, and that might give your graph a little better picture. Okay, and then we can find out again what the relative minimum or maximum and absolute minimum maximum are, if there is any, and we can figure that out. Okay. Again, you can do that on your own, the graphic calculator, or we can wait till class to do that one. And let's see if I got this one a shade under decade. Yeah, 26 minutes. Cool. All right. So, sorry that one was so long. The next one is not as long, so that won't be so bad. All right. Bring your questions to class, and I'll do the best to answer them.